Hello, this is Dr. Mears, and today we are going to be learning about function notation in our course Applications and Interpretations SL1. Function notation, y equals f of x, means that x, an element of the domain, the input, is mapped to the function of f to y, an element of the range, the output. Let's dive into this. First, how do we say f of x? F of x is read f of x. If y equals f of x, then x is said to be the independent variable, the input, everybody. And y is the dependent variable, the output. We are used to writing equations such as y equals x plus 1. So what this means is instead of y equals, we can now use f of x equals x plus 1. So when you see this f of x, you automatically know that it's going to be a function, that one element in the input is going to always be mapped to one and only one element of the output. So you might not see that y anymore, you might see this f of x because it lets you know, hey, we have a function here. Okay. Different variables and names can be used for different functions, such as d equals v of t, m equals c of n, and so on. We can also write it the other way around. So you might see v of t equals d, or you might see c of n equals m. So it could either be written this way or flipped this way. Either one, just to let you know. Okay, well, let's learn how to work with these. Let's look at some examples. Example number 1, consider the function f of x equals x squared plus 1. We need to find the value of f of 2. So what they're saying is this 2 is your x value right here. So this is your input. So what they want you to do is they want you to input it in for this x. So we're going to write it. F of 2 equals 2. So in place of the x, we put the 2 squared plus 1. Now what we can do is exponents first. 2 squared is 4 plus 1. So f of 2 equals 5. So what we did is we input the number 2 and we got an output of the number 5. So we input the x value and we got an output of the y value. That's what a function is. That's exactly what this means. We input and we get an output. And remember, it could either be written like this or it could be flipped around. So both means the same thing. You have to find your input and you have to find your output. We could have also done this in the calculator. The beauty of this course is that we can use a calculator for everything. So what we could do is we can do 2 and then see this little square button down here. We could press squared and then plus 1 and we get 5. Okay. Part B, determine whether the point 526 lies on the graph of the function f. So if we graphed this, actually let's graph this. Let's see what it looks like. Let's see what we're doing. So I'm going to put in, remember my x button is right here, xt theta n, that's my x button. And then I'm going to push my square button, plus 1. I'm going to zoom, and you know what, let's do zoom standard, so zoom 6, remember it gives us that nice 10 by 10, let's see if we can see anything. Oh, very nice, okay. So here's the graph of f of x equals x squared plus 1, that's what it looks like. Now what they're saying for this question is, does this point, 526, is it on this blue curve? So if we went all the way over to 5, and then all the way up to 26, will we still be on this blue curve here? And I'm not going to do it on the graphing calculator. We're going to check it using the function. So I just wanted you to know what we were actually doing before we did it. So let's check to see if that point is actually on my curve or is it someplace over which is off. So this is on, that's off. All right, how do we do that? Well, we use substitution. We're going to input 5, which is our x, and we're going to see if we get the output of 26. So we're going to input 5 equals 5 squared plus 1. F of 5 equals 5 squared is 25 plus 1. F of 5 equals 26. So here's my x is 5, and I got out my y of 26, so that checks out. So these two numbers have to be the same as these two numbers. So we know, yes, it lies on the graph. So going back over here, it's definitely on our graph. Okay, number 2. Let's apply this. The price in dollars of a motorcycle T years after purchased is modeled by P of T equals 15,000 minus 2,500 times T, and T is going to be between 0 and 6 years. So what this means is that our time, I guess that we owned it, is between 0 years, that's when we bought it, and 6 years, I guess that's maybe when we sold it, or that's just the ending number of years. So remember, this is years, so between 0 and 6 years. Okay, first, state the independent variable and the dependent variable. So remember, the independent variable is our input right here. Our input. Independent input. So that's going to be our T. So let's look. T years after purchasing. So independent variable is going to be T, which is going to be number of years after purchase. Okay, and our dependent variable is the output. So the output is going to be our P. So the dependent variable, and let me move this down, sorry, is going to be P. What's P? P is price in dollars after it was purchased. So we can even do P of T here. I like using that. Price in dollars. That's it. Yay. Okay. Now we're going to be using this for our next one. Part B. Find the value of P of 0 and state the meaning of P of 0 in this context. So first, I'm just going to write the equation down right on top. I like to have it here. 15,000 minus 2,500 times T. So times T. And our time is between 0 and 6 years. All right, so what they want us to do is input 0, and let's see what it means. So P of 0, let's input 0 first. 15,000 minus 2,500 T. Perfect. Okay, let's put it in our calculator. Oh, if you're on this graph, if you see the blue button here, you can just press second and then mode, which is really the quick button. Okay, so whoops, we're going to put 0 in, so I need to replace T with, yep, everybody, replacing T with 0. Okay, now we're ready for the calculator. So we're going to do 15,000 minus 2,500 times 0, and we get 15,000. So P of 0 equals 15,000. All right, what does this mean? State the meaning in this context. Okay, so first, 0, that's the number of years after I purchase it. Well, if the number of years after I purchase, if it's 0 years, this must be the initial or the start price of the motorcycle. This is what I bought it for. So this is the initial price or start price of the motorcycle. Is 1, Okay. There we go. So that's how much I purchased it for. Now, here's a hint, everybody. You are going to see me ask you for the initial price or the initial amount or the start point or the start price or the start amount or input 0. You're going to see this. This is going to be a huge question. You will see it over and over. You need to know that you are going to be inputting 0. If I ask you for this, what is the initial or the start? You are going to be putting in 0. Pretty please, star this on your paper because you are going to be going back to it. Okay, next, part C. Find the price of the motorcycle 1.5 years after purchased. Okay, so what are they asking? They're saying, okay, this is years after purchase, so we have a new T. So they're going to want us to input the new time and see how much the price is. Well, let's do that. 15,000 minus 2,500. Well, 11,250. Okay, so 1,1,2,5,0. So after 5 years, nope, just kidding. After 1.5 years, our price decreased to $11,250. And that's what happens, everybody, with cars, motorcycles, boats, anything, any purchase like that. Once you take it off the lot, once it's yours and you own it and you leave and you start to go home or somewhere, anywhere you want, your price starts to go down. So it will never be worth that $15,000 again. I mean, I guess maybe if you have an older automobile and you restore it, there's other situations. But, if you just walked in, bought a motorcycle, as soon as you walk off the lot, the price is it's going to go down. It's not going to be worth as much as you paid for it in the beginning, for the most part, normally. Okay, part D. Find the value for T for which P of T equals 6,250. Interpret this value of T. So what did they give us here? Well, they gave us the output, and they want us to find the input. So we don't have T anymore, everybody. We only have the output. We only have the price that's put out. So this is going to be 6,250 equals. This is the output side. This is the output side, okay? That is the in. So we're going to write 6,250 equals 15,000 minus 2,500 times T. This becomes a solving problem. So let's solve this. The first thing that I need to do is look at the 1,500 and I need to subtract it because it is a positive number. So I'm subtracting it from both sides. 6,250 minus 1,500 is going to give us a negative 8,750. And that equals a negative 2,500 T. Be careful, bring this minus down. It now becomes a negative. Then, because this is linked by multiplication, we are going to divide it. Negative 2,500. Negative 2,500. When we divide it out, we are going to get 3.5 equals T. Here is my answer, everybody. Okay. So that's my time. So interpreting the value of T, that means after 3.5 years, the motorcycle will be worth 6,250. So this is one that we had to do backwards, right? We don't have a nice easy input. We were given the output and we had to go and find the input. So there you have it. After 3.5 years, it goes down to $6,250. Wow. That's where it started, everybody. My goodness. Okay. Comment on the case That's a t. T equals 6. Comment on the case t equals 6. Okay, so first I can say after 6 years. So that's the first thing, because they gave us the t, correct? So they gave us the input. So the input, remember, is the years after we purchased it. And so after 6 years, let's see what it's going to be worth. So let's actually input it and see what happens. I have a guess what happens after 6 years, which is why they might have said that the time, remember way back when, the time is between 0 and 6 years. So let's see what happens though. All right, don't write T there. What are we inputting, everybody? That's right, 6. Okay, let's see what happens. Oh, I was right. I thought that. It's 0. So we input 6 years. We have 0. So after 6 years, what happens, everybody? It is worth nothing. Wow, 6 years. That's it? Huh. I guess, in the real world, you do upkeep and you get oil changes, and hopefully, it'll be worth more for longer. But in this case, after 6 years, it's worth nothing. If we tried to sell it, it's not worth anything. Okay, and what's the last thing? Let's sketch this function. So sketch the graph of this function. Here are my directions for graphing a line. I also did this in functions, the definition video, functions and applications and interpretations. If you want to go look at that, it's also on my YouTube. But let's graph this line. So what we're going to do is we're going to press y equals. So y equals is right here, y equals. And we can clear out anything that's in there. And we're going to put in 15000 minus 2500. Now, we don't have the T button, but we have an X that will appear. So see this X, T, theta, N button, right? We do have a T, but it will only show up as X, which is fine. So we cleared it. We entered equation. Now we could press zoom. And zoom is right here, this middle button. And it says you need to use zoom fit or zoom standard and then zoom in or zoom out. So we're doing a lot of zooms here. Zoom standard only gives you a 10, it goes from -10 to +10. So, and we have 15,000. So I think what I'm going to go down to is zoom fit. That's if you just keep pressing the down arrow button. And let's see what happens with zoom fit. It gives us a nice fit. And remember, this is only a sketch. And so what we're going to do is we're just going to sketch this out because it says sketch. So we don't need to be perfect details. So we can just sketch this out. And remember, label. So this is going to be when we label it, let's label it properly. So remember, we have T and we have P of T, okay? And then just like what it looks like on the calculator, right here. And let's label let's label 1 point. We know this point is going to be 6, 0. We got that from here. Remember, the T is 6. We input 6, and we got an output, or P of T of 0. It's nice to label a point. This point up here would be pretty high because we would have to be going all the way. This is the initial price, so this is the y-intercept. Anytime they ask for an initial or a start, it's the y-intercept. So this point for the y-intercept would be here. And this would be 0, 1, 5, 1, 2, 3. So this is the y-intercept. And this is the x-intercept. And usually our x-intercept is where something ends. And y is where it begins. Sometimes for certain things, there's most of the situations that we're going to see, this is what it's going to be. But there's other situations, of course, where it might not end there. It might be something else because it could go below, which is absolutely fine, like sea level, you can go below. So I'm going to stop there, and we're already at 20 minutes. This has been applications with function notation and in applications and interpretations. I hope it helped.